Hi everyone, and welcome to Mike Likes Robots. Today I want to talk about another AWS service, AWS IoT SiteWise. SiteWise is used for collecting, analyzing, and modeling data about industrial equipment. Let's say you've got a wind farm of wind turbines. You can model each wind turbine and its power generation, as well as the whole farm of wind turbines, and calculate things like the average power generation across the whole wind farm. You can also use it for non-industrial equipment, anything that you can model in SiteWise. And I'll be showing you how to model a robot and a robot fleet today with only a battery charge, but we'll see what useful information we can get from that. There's three main areas of SiteWise that I want to talk about today: the collection of data, the modeling of data, and the monitoring of data. Let's start with collection. To talk about data collection, let's take a look at the console for SiteWise. We can see this how it works diagram, and if we take a closer look at this diagram, let's zoom in a bit. It's got those sections that I was just talking about: collecting, modeling, and monitoring data. It's also got this large box underneath for SiteWise Edge, which is the main way of collecting data, I would say. So SiteWise Edge is, if we can go to the gateway section, SiteWise Edge is a way of deploying software to a server near the equipment that you want to monitor. And it has support for protocols like OPC UA, which is an industrial standard protocol, so you can easily connect it to the equipment already there. So if we quickly take a look at the options for creating a gateway, we can immediately see that it's based on Greengrass. So if you don't know what Greengrass is, I'll link my video on it. And if we take a look at some of these options, we can use the default setup. There's a data processing pack, which lets you calculate transforms and metrics on board. I'll talk more about what those are later in the video. SiteWise Edge allows you to publish data automatically into SiteWise, so that it's all collected together. So it's the simplest way of collecting data for SiteWise. In addition to SiteWise Edge, there's a number of other ways you can use direct API calls, which is what we'll be doing in this video, or you can use IoT rules or a number of other ingestion methods. But I won't be covering all of those today. I'll likely be using a few of them in future videos, so we'll take a look at them then. Now that we've taken a look at some of the data collection, let's talk about data modeling. So every piece of industrial equipment will have an asset model created for it. The model contains information like its serial number and what measurements need to be taken about it, and how it connects to other models. For instance, a wind farm would have a number of wind turbines associated with it. Once you've defined the model, you can define assets, which are instances of that model. So one wind turbine model can create a number of wind turbine assets, each of which collects data about a particular wind turbine. So let's take a look in the console about how we can create our own models and assets. We'll go into the models section, and first we're going to create our own robot model. We'll call it a robot model. We can define an attribute, which would be like its serial number as it suggested, or its manufacturer. Let's go with the manufacturer here. And there's a default value. For us, we'll just set it to fix me, meaning someone needs to come and change this. For measurement values, there's a lot that you could measure about a robot. I'm just going to use one particular value to make the demonstration simpler, and that's its battery charge level. So I'm going to define battery, which is measured in percentage as an integer. And that's our measurements done. Now, we will be defining transforms and metrics, but for now, that's all that we have in our robot model. So that's great. We can now create instances of a robot. We'll also create a robot fleet model. This is how we're going to collect multiple robots into the same fleet, the same collection of robots, and measure things about the whole fleet at once. So we'll create an attribute. Our fleet is going to have a location, and that could be anywhere. So we're just going to, again, put fix me and leave it as a string value. There won't be any measurements, transforms, or metrics, but there will be a hierarchy definition. Hierarchy is the way that you define how models link together. So one fleet can contain robot assets. So we're going to create a robot hierarchy, and link it to the robot model. With that, we've modeled a fleet with a number of robots inside it. Now we want to create individual assets. So the first thing, we'll create 1 or 2 robots. We select robot model, give it a name, like robot 1, and that's all we need to do. For the attribute, the manufacturer, we'd need to edit that in later. I won't do that for now. Create another one called robot 2 and create asset. Now we want to create the asset that links them together. We want to create a fleet. So let's create a fleet asset, which we'll call fleet 1. Again, we'll leave the description empty and create. Now we have this layout of our assets, a fleet with no robots inside it and 2 robots that don't have fleets. So our last step for this system is to link the robots to the fleet. To do that, we'll click on the fleet, we'll click associated assets and see that there are none there. So to add them, we're going to edit them. Edit the asset, the fleet asset, and add associated asset. So the robot is the hierarchy, and we're going to add robot 1 as an asset and then repeat that for robot 2. And that's it. Now we can take a look at our assets. Our fleet expands into robot 1 and robot 2, and robot 1 has a battery level which has never been measured. That's our modeling done and our asset creation complete. The last of the 3 sections to talk about is monitoring. Now, SiteWise has a monitoring capability built in called SiteWise Monitor. It lets you create a portal, and that generates a website that lets you graph different measurements about all of your assets. It also allows linking to other services like Grafana, which is a common tool for modeling and graphing data, and TwinMaker, which is another AWS service that I will talk about in another video. Those are out of scope of this video, so let's take a look at the portals page in the console. Here we can see the SiteWise console. We'll go to the monitor section, portals, and I've already created a portal, although there's no dashboards or anything within it. That's just to save some time because creating a portal does take a little while for the portal to actually start up. So we'll go through the create portal options to show you what they look like, but I'll skip the actual creation step because it's already complete. So we'll give the portal a name. We'll call it Robot Portal 2. We don't have any branding. For user authentication, you can set up I normally use the IAM Identity Center. It's how I sign into my account anyway. So I'd recommend you do that. If you need help doing that, let me know and I can create another video on it, but there are also instructions online. For a support contact email, I can put robots@big.com. And then you can either use an existing service role or create a new one. This is all you need to do to create a portal. Clicking next will generate that portal and allow you to sign into it. To be able to show you what the portal looks like inside, it's much easier if we have some data to play with. So let's stop now and take a look at how to actually upload data into SiteWise using a script. So this is an EC2 instance, the same EC2 instance I've been using for the IoT demos, and I've got this script inside it. I'll provide a GitHub link to allow you to download that script and try it for yourself. It's very simple. Essentially what we do is we pull the data out of SiteWise we need, so the IDs of the robots that we need to update, and then it does a very simple charging cycle. The robot discharges a bit every second, and if it goes too low, it will recharge back up to full very quickly. While that's happening, it will upload all of that data into SiteWise using this batch put asset property value. This is an API call essentially. So given the correct data, which is set out in this format, SiteWise knows which assets you want to update, which values you want to update, and you can give the value here, the integer value self.battery. So let's get this set up and ready to go, and we'll pull the data we need from SiteWise to make that work. We'll start by opening a terminal, and we're just going to install dependencies. So there are instructions in the README but they're very simple. They're essentially create a virtual environment, activate it, and install the only dependency into it. So let's go through those steps without opening the README. First, we need to make sure that virtualenv is installed. So there's instructions in the README for that. I already have it, so I'm just going to use -m virtualenv. Then I'm going to activate it. I just clicked yes on that VS Code prompt, which it automatically recognizes that a virtual environment has been created and offers to use the interpreter in there, which is great because once we've installed the Boto 3 requirement, our editor will understand that it exists and how to use it. So let's activate the VN and install our dependencies. We install -r requirements.txt. That will install Boto 3, which gives us full access to our script. At this point, we can run the script and it will do nothing because it hasn't been given any assets to update, but we can watch it tick every second. Must be at least one entry per request. So it won't even work because the SiteWise uploads fails with 0 entries. So let's get the data to make our script work. Off camera, I've created an extra 3 robots, so we've got a total of 5 robots, and we'll display data for all of those at once. So if we expand this fleet out, we can see robots 1 through 5. We can click on robot 1 and take a look at the measurements tab. Now the ID here is what we want for the battery ID. This is what tells SiteWise which property needs to be updated. So we can paste that into this box here. Now we want to get the asset IDs for all the robots. And for that, we're clicking this asset ID. Now I'm going to copy all 5 of those into the list, and I'll skip to that so that you can see what the result looks like. With that, our script is set up. We have our battery property ID and all 5 of our robot assets ready to start simulating battery data. Now, there's one thing that I didn't talk about before during the script setup stage, which is that each robot has a battery and a battery health field. These are randomly generated by the constructor, and the battery is a random value between 30 and 90%, and the battery health is a float between 0 and 1, which determines how fast the battery discharges for the robot. We're going to be trying to estimate a battery health using SiteWise tools. It won't be the same as this 0 to 1 value, but it will at least be able to tell the difference between robots so that we can model it over a fleet. So let's take a look at it running now. We run python main.py, and we can see that the ticks are starting to come through. Tick complete posted 5 statuses. Now if we take a look at our assets and look in the measurements tab, we can see these latest values starting to come through. And that's our script working. We're now simulating data for our battery levels for 5 robots, all the robots in our fleet. Now our simulated data script is generating data for us. We can actually make some graphs using SiteWise Monitor to see how our fleet health is. So let's open up our portal by copying the link and opening a tab. We navigate to the portal, we can get rid of this, and we'll create a project from our fleet asset. So we'll go to the Assets tab, add asset to project, click this asset, and we're creating a new project. So we'll just call it fleet project. You can use more descriptive names when you're running it for real. So with that, our fleet and all of our robots are contained in this project. Now we can create a dashboard for it that we can use to start graphing data. So to begin with, we'll just take one robot and pull its battery data onto the screen. And there we can see our discharge cycle happening. Very quick recharge followed by a slower discharge. Now what we can do is add multiple different graphs to the same dashboard. So we can add robot 2 next to it. And then if we save this dashboard Now, whenever we open up our monitoring portal, we'll have this dashboard immediately giving us an overview of everything that we've set up already. Let's edit this to have some slightly more useful information. We can have all battery levels. And on this, we'll take all the battery levels from all of the robots and graph them onto the same graph. Now that's starting to get a bit overwhelming, but we can see from that that the robots do have different discharge cycles. So they're not all starting at the same point and they don't all have the same slope. So they do have slightly different characteristics in their discharge cycle. And we're going to use that to use some transforms and metrics that I was talking about earlier in order to estimate the battery health of each robot and therefore the battery health of the fleet. So let's look at how we can do that. To be able to calculate an estimated battery health for each robot, we would edit the model. The model is where we define calculations to be performed based on the measured data. So let's take a look at our robot model. Now, if we edit this, we can create a new transform definition. What we're going to measure here is the difference between the current measured point and the last measured point divided by the time between the samples. Now, the script is running at 1 second per sample, so that division won't do anything, but we'll leave it in so that it's a true differentiation. So we'll create a new transform, we'll call it battery slope, because it's measuring the slope of the battery discharge. The unit is percentage per second that's changing, and we'll leave it as a double. The formula for this will be the battery level, which we can specify using curly braces to reference a measurement. So battery is our only variable. And then we want to subtract the previous value, which we can use with the function pre-trigger. That means the value before the one that triggered this calculation. So we can open that and again reference the battery. Now that calculates the difference between the current point and the previous point, but we still want to divide by time. So we're going to wrap this in brackets for the left side of the division operation, and on the right side we'll put a new pair of brackets and figure out the timestamps of those two values. That's simply going to be the timestamp of the first battery value subtract by the timestamp of the pre-trigger of the battery value. Now we're getting into a lot of braces, but that should be correct. Now we'll save this and we can start to look at that graph appearing in our portal. We'll edit our portal, shrink this down. And our new battery slope transform has started to be calculated, although it doesn't have any values yet. So we'll wait for the first of those values to come through and then we'll start to see it being graphed. So we can see that battery 1 is giving us a value of -3% per second. So it's losing 3% of its battery per second. We can also add another couple of robots into this graph. Let's take one that's losing a bit more per second. It looks like this purple one is, which is robot 1. Let's try this orange one, robot 4. So robot 4 is losing twice as much battery per second as robot 1. But that's not an estimated health, and it won't help us across the fleet. So what we'll do now is add a metric, which is calculated every minute, and that will tell us an estimated battery health percentage that we can average across the whole fleet. So the way we can calculate a metric for the battery health is again by editing the robot model. And we can edit this, and where before we added a transform is used to convert the measurements from one form to another, such as converting Celsius to Fahrenheit or the other way around. A metric is taking a block of data over a time interval, if we add a metric, we can see the default is 1 minute, and calculating something based on that. So the average value, the maximum value, and we're going to use it to calculate an estimated battery health. So first we'll give it a metric name, we'll call it battery health. The data type will be a double, and our formula, well, we need to work that out. So firstly, our spikes are our values coming in from our battery slope are -3, -3, -3, 100 as the battery recharges. The first thing we want to do is get rid of those large positive values. So we'll take the minimum of the battery slope and 0. Now all of our values will either be negative or 0. We'll still get 0 values in there which will affect the average value if we take an average, but that's much better than a huge positive value skewing our data. So our minimum in this case will be for robot 1 -3, -3, -3, -3, and that means a more healthy battery than our robot 4, which is -6, -6, -6. So what we'll do is we'll do 100%, subtract the slope. However, because the slope is negative, we'll add it. So 100 plus -3 will give us 97. But that's not a very big change in robot battery health, so we're just going to scale that up by 10. So this value should give us, for robot 1, 10 plus 10 times -3, or 100 minus 30, or 70%. The same calculation for robot 4, which is giving us -6 on the slope, would be 100 minus 60, or 40%. So through this, we can calculate a battery health value for all of our robots. All of the other options are fine, so we'll save that, and then we can try to graph our battery health on our dashboard. So first I'm going to save and refresh to make sure it's got the latest information. Now I'm going to edit it and take a look at robot 1. And then I'll save this. And because the metric is calculated every minute, it might be a while before we have any data points coming through. So now we'll wait for that first data point to arrive. And we can see our first battery health value has come through, which is 70% for robot 1. So let's add all of the robots to this graph. Robot 2 has a battery health of 60%. 3 is 80%. 4 is 40%. And 5 is 30%. We can blow this up a bit. So we can see all of our robots have different health values. Now, of course, our script is a fixed health value that it's going to keep using. But you can imagine that if you kept tracking this data over a real robot fleet over a long time, you could start to measure that the battery health is actually decreasing. You can even do things like set alarms for when the battery health goes below a particular value, which lets you know that you need to perform maintenance on the battery or take the robot out of service. The last piece of the puzzle for our battery health picture is to adjust the fleet model to calculate the battery health across the whole fleet. We'll add a measurement for the minimum, the maximum, and the average battery health. So we open the fleet model and click Edit. Now we're going to add a metric definition. We'll call it average bat health, and it will be an average of robot arrow battery health. That will be calculated every minute. We can repeat the same for the minimum and the maximum. Now when we save that, we can go into our portal and add a new graph for the whole fleet. We can plot all 3 points onto the graph, and then we'll save the dashboard and wait for the first piece of data to come through. And our first values for the aggregate metrics have come onto the graph. They're only single points, so they're quite hard to see, but again, you can imagine that these values will change over time. You can try and maximize these values to make sure your fleet is in the best possible shape. So we can see from the graph that the average is 56, the minimum health is 30%, and the maximum health is 80%. I'm sure if we sum these values and divide by 5, we'll find the same result. And that's AWS IoT SiteWise. We've seen our 3 major categories. We saw data collection, we saw data modeling, and we saw data monitoring. For our example, we collected data using API calls, although it's also possible to use SiteWise Edge, IoT rules, or a number of other ingestion methods. We saw data modeling, where we calculated for each robot in a fleet what its battery health level was and the battery health aggregates across a fleet. And we saw monitoring, where we created a dashboard and graphed a number of values about our robots within that dashboard. So take a look at the code, I'll link it in the description. Let me know in the comments if you like the video and if there's anything else you'd like to see. Thank you for watching, and I'll see you in the next one.